So this time we've got a slightly different equation. We have a equals b minus c. So at the moment it's solved for a, and we're going to solve for b. So same idea, look what we're doing to b. So at the moment we're going to subtract c. So we want to do the opposite of that. So instead of subtracting c, we're going to add c to both sides. That cancels, that's why we do it. So we get left with b, which is what we're looking for. And a plus c is just simply a plus c. Once again, we can use our symmetric rule if we prefer. And then we end up with an equation for b. Now on this question also I asked to solve for c, so I'm going to go back to this step up here. Now this is actually a more difficult question, and the reason this is a more difficult question is I don't have c here, I actually have negative c. Now whenever that happens I always tend to add c to both sides, which is what I did on that first question. So when you add c to both sides, this cancels and I get left with a plus c equals b. And then now I try and solve this equation. So at the moment I'm adding these two things together. This is a positive a, so I'd like to move that to the other side. So instead of adding a to both sides, I'm going to do a subtract a from both sides. So I get left with c, because this cancels, and then b take away a is b minus a. Now there is another way of doing that question, which I don't really like quite as much. I could subtract b from both sides here, and then I get left with negative c. And then I can divide both sides by negative 1. And remember, if you have two negatives when you divide, that becomes a positive. And when you have a positive divided by a negative, that just becomes a negative. So you still end up with b minus a, but sometimes it's confusing when you've got multiple negative signs on. So I prefer to bring this to the other side first.